Hey you guys, this is Miss Thomas. I hope you guys are doing well. This is definitely odd teaching this way, but I want to try to continue to teach you guys, and hopefully you guys can understand what's going on. If not, you certainly can either send me an email or send me a text through Remind. Those are going to be the best ways to get in touch with me. I'll pull those up again, my email, just so you know. Here's my email, and Remind is the other good way. I'm going to ask you guys each day, or I don't know if I'm going to do a video every single day, but a lot of days I will, because I think that's going to be the most helpful. And I'm going to ask you to respond to maybe 2 or 3, 4 questions. We're not going to do a full class. Obviously, when we do class, I'll give you time to work and stuff like that. It's just a little bit different. So I'm trying to find like the most important things that I think you need to know and pick those things out. So today we're going to try to talk about graphs. Okay, so we have really gone very in depth with sine and cosine, but now we need to learn all the other 4 trig functions. So we have the reciprocal of sine, which is cosecant. So that's the one we're going to do. So I'm still perfecting this, so y'all just bear with me. So the reciprocal of sine is cosecant, as we know. So we're going to be kind of coming up with what that graph looks like today. And sorry, that's pretty bad. It's going to really boil down to, do you remember the relationship between sine and cosine? And I already just said it a moment ago, they're reciprocals of each other. And so if we can take the sine graph and remember what it looks like, and then think about reciprocating each of the points, it will get us the cosecant graph. Okay, it's not quite as easy as what I'm making it sound like, but it certainly will help, and I'll walk you through that. So let's just refresh our memory. Sine has a period of 2 pi, and so then our tick marks are as such. That we got really good at the past couple of weeks, so I think y'all should be okay there. All right, I'm going to get a different color and plot the points. So if y'all remember, where does sine start? Sine starts at the origin here, and then it goes up on the right, midline, down, midline, and then it does the opposite on the left. So it goes down, midline, up, midline. And then remember, this is curvy graph, and then it has arrows and they go in opposite directions. So we're going to do something very similar for cosecant, and I didn't say this, I should have. I hope you guys will follow along with me. Pause the video as you need. You know, if I'm going too quickly, you can pause it. That's kind of the nice thing about a video. But I do hope you're kind of copying this down, like pretending as if I'm teaching at the board and you're taking some notes, okay? So let's remind each other. We have a period of 2 pi here, and we have an amplitude of 1. Okay, so we're going to kind of see how that works with cosecant. So I hope everybody can see there's an imaginary 1 here. And so our b is also an imaginary 1. So we're still going to follow that same protocol as before, where it's 2 pi over b. And so in this case, because it's 2 pi over 1, it's still 2 pi. Okay? And so then our amplitude, we're actually going to hold off on and talk about in just a moment. Okay, so now this is going to be kind of the difficult part to understand. So y'all really try to focus in here, okay? What I'm about to do is I'm going to take each of these points, okay, each of these points, and I'm going to reciprocate them. So basically, not like physically, not like what it's at the top is going to go to the bottom, nothing like that, but like whatever this value is right here, we're going to reciprocate. So, and when I say that value, I mean the y value. So what is the y value at this point right here? Well, it's 1, okay? So if I reciprocate 1, y'all remember that means it goes on to the denominator, like that. Well, if I reciprocate 1, it still is the same thing, okay? So down here in this cosecant graph, our first point is actually going to be in the same exact location, okay? And then, do y'all see it would hold true here, because that's also a 1. So it would still hold the same exact thing. So, or the same reason. So it's going to be at 1 as well. And then likewise, these guys down here are at -1. Well, if you reciprocate -1 like that, remember it goes to the denominator and a 1 has to hold its place, is still going to equal -1. So these aren't going to change location either. Okay? And so we can go ahead and label. I should have labeled already. That's my bad. Let's go back and label our tick marks. Okay, so this should be a 2 pi. Remember, we divide by 4 to get the first tick mark. We divide by 2 to get the second tick mark. Divide the last one, by 4, and divide the last tick mark or the period by 2. And then we are, sorry, I'm trying to erase that little mark I made right there. And then to get the third tick mark, we times the first one by 3. I think y'all have got those memorized. Okay, so now we need to worry about these. All the rest of the points are now at 0. You'll see they're sitting right on the axis. Okay, well, what happens when we reciprocate 0? We have to put it into the denominator, and what does that equal? Well, when 0 is on the denominator, sometimes we have trouble with this, remembering. Sometimes some of us think it's 0, some of us think it's undefined, but we really got to keep this straight. It's actually undefined, okay? So how do we graph undefined? Well, the answer is you can't, okay? Undefined means it does not exist in that spot. And if you remember back from, Algebra 1, when you learned about asymptotes with exponentials, that's what's going to occur here. So every place where we originally up here in the sign, let me get a highlighter and see if this can highlight. Everywhere we had up here where it was 0, so basically, do y'all see it's every other point where it was 0 is now going to be an asymptote, okay? And that means it's this imaginary line that will never, ever, the graph will never ever touch. So we're going to have an asymptote here, and we're just going to draw it with a dotted line. We're going to have an asymptote here, and we're going to have an asymptote here. So it's literally every other tick mark. Okay, so 2 ways you can remember this. So the thing that I try to do is I try to always go back to it has to look like sine. Okay, and what I mean by that is here with sine, we always went, let's see if I can highlight it with a different color. Let's use pink. With sine, we always went up on the right and then down, and then on the left we went down and then up. Do y'all see this trend? It's the same, up on the right, down on the left, okay? Now the weird thing about this is, how in the world do you make a graph look right when there's just a point? You can't connect them, because I don't know if I made this clear, but an asymptote is something that you can never touch. Okay, so like this point up here cannot go down like that because it's crossed the asymptote, so that's a no-no. So here, I'm just going to go ahead and tell you, but this is what the graph is going to look like. It's basically a bunch of parabolas, if y'all remember that word from when you learned about quadratics. Like this. You learned about quadratics in Algebra 1 and Algebra 2, so hopefully parabola doesn't sound new, but it's basically just the U shape if it does not sound familiar to you. And there's our graph of cosecant. So its period is still the same as sine, because if you notice here, I'm used to pointing, so I'm having to draw, sorry. So from here to here, the graph goes up and then down, and then do y'all see from here to here it does the same thing, up and then down. So that's the period is still 4 tick marks. So what we see here in this graph is 2 cycles. So the period still stays the same. Now the amplitude is a little funky. The amplitude is actually none. So that's new. You may want to put a star by that. Okay. Why is the amplitude none here? Well, because amplitude, if y'all remember, is like another word for height. Height means how tall something is. Well, if you notice, this parabola is going to keep going up forever and forever. This one's going to keep going up forever and forever, and then likewise these, but they're just going down. So there's no way to measure the height. Some of us might want to say infinite or infinity or negative infinity, but that's still not a measurement. It's not like some way we can put a number on it. So from here on out, you need to really make sure you understand that the amplitude is going to be none. All right, so pause, make sure you get all of this stuff. If you didn't really understand the reciprocal business over here, it's really not the end of the world. What I really need you to understand, of course, that's like, how we got to our answer. But I would think that the most important thing at this point is knowing this graph. Just understanding what it looks like. It's going to be parabolas. It goes up on the right, down on the left, just like sine. All right, so now we're going to do the same exact thing for cosine. All right, so I'm going to go ahead and review cosine. I think we're all pretty good about this one as well. So our period is 2 pi and our amplitude is 1. And what does cosine do? Well, cosine goes, it starts up at the amplitude and then it goes midline, down, midline, up. And it's very symmetrical. It does the same thing. And what letter should we be seeing? We should be seeing a W. Okay? So there's cosine. I think most of us, we got really in depth with that on Tuesday, which was the last time, gosh, it's almost been a week since I've seen y'all, since we had our test, which those grades are in, so make sure you've checked those out. All right, so we're going to do the same thing for secant. And you guys, it's really, if you followed what I just did in the previous graph, it's very, very similar. We're just going to reciprocate each of the points or think about each of them being reciprocated. So if I take 1 and reciprocate it, it's still going to be 1. So all 3 of these points are going to stay the same down below. Because if I reciprocate 1, it still remains 1. Okay? So I'm going to put 1 here, and it's at the end and at the end. And then likewise, it's going to be the same thing down here at -1. And then what did we say just a moment ago is going to happen for these guys? So like for this one, this one, this one, and this one, all of them are located at 0. So when I reciprocate 0, that equals undefined. And what did we just say that's going to look like on the graph? It is going to be an asymptote. Okay, so here at the first tick mark, it's going to be an asymptote. And every other one just like before. So it is a little tricky to remember where the asymptotes go, but I just think about cosine. Cosine starts up at the amplitude, so does secant. And then if you can just get this first dot plotted right here, then it's just asymptote down, asymptote up, asymptote down, asymptote up. And what I mean by that is start here, asymptote, and then go down, asymptote, and go up. And it still should make that W. Now, you're not connecting them, but it still should make that W. And then it's just parabolas like before. So these are going to go up because they're at the top. And these are going to go down. Okay? I hope that makes sense. Now, let's discuss period. Is still going to be 2 pi because this is a little bit harder to tell, but it still takes 4 tick marks for it to repeat itself. Okay, so this one is like it's half of it pointing up, a full one pointing down, and then half of it going down, and then it's going to repeat itself. Okay, so it's still 2 pi. And then the amplitude, what did we just say on the previous slide? Well, if these things are going up forever and down forever, you can't really put a height on it. So the amplitude is none. Sorry, ran out of space there. Okay, that is going to be very important because we're going to be used to saying amplitude is 1, like up here, but amplitude is actually going to be none. All right, I'm going to work through a couple examples with you, and then I'm going to ask you to do a few on your own. And I want to show you kind of how I think through and work through these things. All right, now this number is going to be my quote-unquote amp. Now the reason I say quote-unquote is because technically the amplitude is always none. Remember how we just said that? But this amp is going to help us understand that it's a vertical stretch. Remember, because A is greater than 1. All right? So that means my y-axis is I'm really going to stretch up to 3 and down to -3. Now, did I change my period at all? Or is my period still the same? Well, my B, is an imaginary 1. So 2 pi over 1 is still 2 pi. Okay? So nothing's changing with the period. We're only changing the amplitude. Well, the quote-unquote amplitude. Excuse me. All right, so now let's kind of go through my thought process and see if it makes sense to you about how to graph this thing. So I got to think, all right, is secant the reciprocal of sine or cosine? It's the reciprocal, because if you have a S, you need a C. Remember how we did that before long ago? So it's the reciprocal of cosine. Cosine starts up at the amplitude, so does secant. So I'm going to put this right here. And then what does cosine do? On the right, it goes down. Well, I have to do an asymptote first, and then it's going to go down, because anything that was on the midline is now an asymptote from cosine. And then it's another asymptote. Asymptotes every other place. And then because I went, sorry, my sister's texting. Then I'm going to go up on the right. Okay. And then it's going to do the exact same thing on the other side. So asymptote down, asymptote up. So just remember, asymptote every other tick mark. Remember, the y-axis is a giant tick mark. And then it's going to look kind of like cosine because it's going to start up at the amplitude and then it's going to go down on both sides. So pause the video, make sure you have all of that written down if I went a little quickly, okay? We're going to do another one. All right, so we're going to put quote-unquote amp because, you know, it's not really the amplitude. The amplitude is technically none, but the quote-unquote amp is going to be 1/2, which means it's going to be a vertical compression, and that's because A is less than 1. All right, so this is your A. Remember, this is your B. Okay, so our period is still going to be 2 pi. Okay. And then we're only going to go up to 1/2 and down to -1/2 on this problem. Okay. All right, so now we're going to do cosecant. Cosecant is the reciprocal of sine, because I have a C, I need an S. Sine starts at the origin, but wait a second, remember, you can't start at the origin because anything that was 0 is now an asymptote. So asymptote starts here. Then what does sine do on the right? Sine goes up on the right, so does this one. Then we have another asymptote. Then it goes down because we have to skip the midline. And then we'll have another asymptote. So it's asymptotes on the ends here and in the middle. And then sine goes down on the left, and then another asymptote, and then up, and then another asymptote. And then we just make our parabolas as best we can. If they're here, we're going to point them upward, and if they're down at the bottom, we're going to point them downward. The only time that we would change that is if we have a reflection. Okay, let's look at 2 more. All right, so we got a reflection here. I need to go ahead and put a star so I don't forget. You know, that's easy for me to do. Okay, now we also have an imaginary 1 here and an imaginary 1 here. This is something that you guys still struggled with even on the most recent test, so I hope that you'll kind of watch out for what I'm about to explain here. Your b is not 1, and it's not 2. Your b is 1/2, okay, because this 2 is in the denominator. Your your amplitude, remember, is always none with these guys, but your quote-unquote amp, if you want to call it that, is just a 1, which means no change, really. It's not stretching or compressing, okay? However, our period is going to be 2 pi divided by 1/2, because remember, it's 2 pi over b. And so now we have to do keep, change, flip, which equals 4 pi, okay? So that's how I'm really affecting this graph, is I'm not really changing the amplitude at all, the quote-unquote amp. I'm changing the period. All right, so if I have 4 pi here, I'm going to divide that by 4, which will give me pi. I'm going to divide 4 pi by 2, which will give me 2 pi, and then I'm going to times this first one by 3. Okay? And now I'm going to set my asymptotes. Okay, so this is secant. I'm going to think through. Secant is the reciprocal of cosine. So cosine starts up at the top. Okay? Now, we have to be careful because it's a reflection. So because of the reflection, instead of starting up here at 1, it's not going to start there, right? Where is it going to start? If it reflects, it's going to start down here. Then we have our asymptotes. Okay? And then it's going to go up. So what letter should we be looking for here? Instead of a W, y'all are used to this, we should see an M. Okay? Let me see if I can make sure I'm clear on what I mean by an M. Now, I don't want you to do this, so if you pause the video, that's cool, but don't do what I'm about to do. I just am trying to make a point here. All right, what I mean by this is if you were to connect these, which I don't want you to do, but if I were to connect them, do you see the M? Hopefully that should help you see what I mean by it's like if you took cosine and reflected it. Okay, so the reflection here basically took all the parabolas that were originally facing up, and now they're facing down. So originally it started like this, but then we reflected it down here. Okay? And originally this one was down here, but then we reflected it, so now it's up here. I'm not going to leave that on there because I don't want to confuse anyone, but that's how we did a reflection. Okay, and now let's do a last one. And then it's your turn. All right, so we have 2 changes here. We have a 2 and a 2, so let's think about that. So our amplitude is none, but our quote-unquote amp is going to be 2, which is a vertical stretch. Okay, that means it's getting taller or, further away from the x-axis. Okay, now our period is going to be 2 pi over b, which is 2 pi over 2, which equals just pi. So that means our 4th tick mark is pi. Okay, and so then we'll go divide that by 4, it's just pi over 4. Divide it by 2, it's just pi over 2, and then times the first one by 3. All right, we don't have a reflection. Yay, that makes it a little easier. So now let's see if we can graph it. Okay, so cosecant is the reciprocal of sine. Sine typically starts here, but remember anything that was there is now an asymptote. Okay, so I'm going to undo that, and now my asymptote is going to go straight. Ooh, goodness, that's not very straight. And then it's every other one. So maybe some of you just want to get in the habit of putting your asymptotes in first. It's not a bad idea. Okay, and then we'll think about what sine does. So sine goes up on the right and down on the left, and then it does the opposite. To me, cosecant's like a nice full picture because there's only 4 parabolas. On secant, there are 5 parabolas. So these are going up and these are going down. And that's every time. So do y'all notice that even though my period changed, you know, my period, oh, I didn't say what that was. I'm sorry. I didn't say it before either, I don't think. So because B, which is your 2, is greater than 1, it's going to be a horizontal compression. Remember, we've really struggled with that. We want to act like it's the same as the vertical stretch, but it's really the opposite. Okay? Let me go back and see if I need to say that with another one. Yeah, let's look at 3. So here, your B is 1/2. So your B is less than 1. So therefore, it is a horizontal stretch. Okay? Sorry about that. And then it didn't happen on 1 or 2, so we don't have to worry about it. Okay, so you can pause the video, go back to any of my 4 examples if you need to, but here's your assignment for tonight, okay? Or in the morning. I want you to try to do these 3. You can do them on your own paper, and I want you to send me a picture either to my email or to Remind. It does not matter. I am making note of who's sending it to me and who's getting it right. I will give you feedback based on if you are correct or not. Okay? So try your best to draw and label everything appropriately, and we will move forward with this tomorrow. All right, you guys. I miss you a lot. I hope you're doing well. Good luck.